6.4 is about adding and subtracting radicals. Now, in order to add or subtract anything, they need to be alike. Remember, like terms, like if you have 3x plus 5x, you can only add those together because they are alike. We can't add 3x and 5y together because they're not like terms. Same thing with radicals. We have to have like radicals. So two radical terms are like radicals if they have two conditions. The same index, which is like square root or cube root or fourth root, and the same radicand, and that's the number underneath. So here's some examples. Like radicals are the first ones. So if you look, negative 7a times the square root of 5 and 3a times the square root of 5. They are both square roots, and underneath they both have 5. So they are like, and we could combine them. Next one, same thing. They are both cube roots, and they both have 15b underneath. These next couple are not alike. So this first one is a square root, and the other one is a fourth root. So even though they have the same number underneath, their indices are different. And then the next one's exactly the opposite. So they're both square roots, the square root of 3 and the square root of 10. But because they have different things underneath, we cannot combine them. So before we do any combining, let's make sure that we know how to tell the difference, if they are alike or not. So for these first couple, all we're going to do is say, are they alike? So A, square root of 2 and the cube root of 2. They are not alike because one is a square root and one is a cube root. C, the next one, square root of 2 and square root of 5. So both of them are square roots, but because they have different things underneath, we still can't combine them. Next one's 7 square root x and, cube root x and cube root of x. Yes, we can definitely combine these guys because they have the same indice and the same radicand number underneath. And with the next one, they're both fourth roots again, but because you have an x underneath one and a 2 underneath the other, it doesn't matter that both of these have a 2 and an x. You need the same thing underneath, so we cannot combine those. So now that we know what we can combine and what we can't combine, let's actually combine some things. So if we start with problem 15, it says that we need to add 3 root 5 and 6 root 5. So pretend these were x's, like 3x plus 6x. Everyone could tell me that it was 9x. So we can do the same thing with the root 5s. If I have 3 root 5s, and I'm adding 6 more root 5s, I end up with 9 root 5. One thing that a lot of people want to do is not only add the numbers on the outside, but add the numbers underneath. Remember, those are just things that we happen to have 3 of, and then we're adding 6 more to. So you can't change what is on the inside. Just like this didn't become 3x plus 6x, it didn't become 9x squared. So the next one, 17, let's hop on over here. We have a couple things going on. So the first thing I'm going to check is they all have the same index. It's all cube root. And then the second thing I need to check for is, do I have the same thing underneath? I have TW underneath all of them. So that means I can combine. If you need to, again, think of x's. If I have 3x minus 2x plus, this is just 1x, I would combine the first two. So 3 minus 2 would give me 1, and then add 1 more to it, I'd get 2x. We can do the same thing with these radicals. So if I have 3 minus 2 plus 1, I end up with 2 of the cube root of TW. Always check to see that you can't simplify anymore. In these first couple problems, we definitely cannot. Next one, similar story. Check to make sure that they have the same index, and then double check to make sure that they have the same radicand. So this one and this one can be combined, but this guy can't be. So what we're going to do is combine the ones that we can, and then leave the other ones alone. So if I take the fourth root of 3 and add 7 more fourth roots of 3, I end up with 8 fourth roots of 3. And then because I can't combine the fourth root of 14, I'm just going to leave it there. And we're done. Sometimes they're not going to be as easy as that. You're not going to have like terms right off the bat. You need to check and see if you can create like terms. So the very first one, let's see what we can simplify and then see if anything can combine. Square root of 36. Hopefully everyone knows that that is 6. And then the square root of 81 is just 9. So this thing simplifies to 15. And if you were to type that in your calculator, you would get exactly 15 also. Obviously, not all of them are going to be that easy either. So let's look at 39 over here. I have 2 square root of 12 plus 48. So let's see if we can simplify 2 root 12. So if you need to make a factor tree, or you can think about what goes into it. So we can take out a group of 2's that we're going to multiply by this 2 here. So I get 4 root 3. 2 root 12 is the exact same thing as 4 root 3. So we didn't change the number, we just changed the way it looked. Now let's do the same thing with the square root of 48. We can break the square root of 48 up into a couple of things. Let's do 4 and 12. 4 is 2 and 2. 12 is 4 and 3. So then 2 and 2. So our pairs, we can make 2 groups of 2, and then a 3 has to stay on the inside. So if we pull out 2 groups of 2, we are pulling out 4, 2 times 2, and then we still have the square root of 3. So now we have the same exact radicals and indexes. So remember we were adding them from up here. So 4 root 3 plus 4 root 3 gives us 8 root 3. Let's do the next one. So right now they are not like terms. I cannot combine them, but if we simplify them, maybe we can. So I have 5 times the square root of 32. If you're looking for perfect squares, the biggest perfect square that goes into 32 is 16. So you can split this up into 16 and 2. And then we would have 5 times the square root of 16 times the square root of 2. Square root of 16 is 4. So we end up with 20 root 2. So 5 root 32 is the same thing as 20 root 2. And now let's do the same thing for the next one. 2 root 50. Hopefully a 25 is coming to mind. We can break that 50 up. And then we would have 2 times the square root of 2 times the square root of 25. Square root of 25 is 5. So we end up with 10 root 2. And now, once we simplify them, we have like terms again. So we can combine 20 root 2 and 10 root 2. Add 20 and 10 up, and you get 30 root 2. And we're done. Last couple problems here. This section's pretty short. 41. I have 3 things to combine, and right now, all of them are square roots, so that's good that that's all the same, but none of them are like terms. So let's see if once we simplify them, they become like terms. So the first one, 4 root 7. I can't break 7 up anymore. So that one has to stay 4 root 7, not changing. The next one is the square root of 63. So let's see what that one can break up into. If you're thinking perfect squares, see what goes into that. 4 doesn't, 9 does. So let's break that up into 9 and 7. And remember, we can write that as the square root of 9 times the square root of 7. Or we could break up 9 and notice that there's 2 3's that come out. So the square root of 63 simplifies to 3 root 7. So far we have 2 things that have a root 7 that we can combine. Let's see if we can combine the last one. So So we have negative 2 root 28. And if you're thinking about perfect squares, think about the biggest one that goes into it, and that would be 4. And 4 goes into 28 7 times. So we can write this as negative 2 times the square root of 4 times the square root of 7. And we know the square root of 4 is just 2 times root 7. So we get negative 4 root 7. So now that we have all of those terms simplified, we can combine them all together. So I have 4 root 7. I want to add 3 root 7. And then subtract 4 root 7. So obviously the 4 root 7's go away, and we're left with a nice simple 3 times the square root of 7. Let's try the next one. It looks pretty messy, but remember we need to simplify and then see if things are like terms. So they're both cube roots. That's a good start. We know that there is a possibility to simplify them. So let's look at the first one. 2s squared is already on the outside, and then I have s squared times t to the 6 on the inside. So if I'm looking to simplify, I can't take out any s's. There's only 2 in there, and I need a group of 3. But I can take out some t's. 3 goes into 6 exactly twice. So I can take out 2 t's, or 2 groups of 3 t's, and that leaves me with the cube root of s squared. So that one's all simplified. Let's see if we can simplify the other one. We start with 3t squared times the cube root of 8s to the 8th. So we still have this 3t squared on the outside. We know that the cube root of 8 is 2. And then if we want to make groups of s's, we can make 2 groups of s's, and there's 2 s's that need to stay inside. So this one looks pretty messy. Let's combine what we have on the outside. 3 times 2 will give me 6 s squared t squared, and then we have times the cube root of s squared. So now that both of these things are simplified here, we can combine them, and we're supposed to add them together. So on the outside I have 2 s squared t squareds plus 6 s squareds t squareds, so that gives me 8 s squared t squared. And then because our radicals were the same is the only reason that we could combine these. Cube root of s squared. Be very careful not to add the stuff on the inside together. And that's it. That is all of 6.4.